Our solar system is a wondrous place, teeming with planets, moons, and asteroids. But did you know that our solar system exists within a giant invisible bubble? This bubble is called the heliosphere. It acts like a shield, protecting us from the harsh environment of interstellar space. The heliosphere is created by the sun. The sun constantly emits a stream of charged particles. This stream is known as the solar wind. The solar wind travels at incredible speeds, reaching far beyond the orbits of even the most distant planets. Think of the heliosphere as a giant bubble blown by the sun. It extends billions of kilometers into space, marking the boundary between our solar system and the vast expanse of interstellar space. The solar wind is a fundamental component of our solar system. It originates from the sun's corona, the outermost layer of the sun's atmosphere. The corona is superheated to millions of degrees Celsius. This extreme heat causes the sun's gases to become electrically charged, forming plasma. This plasma is made up of charged particles, primarily protons and electrons. These particles are constantly being blasted away from the sun. This continuous outflow of charged particles is what we call the solar wind. The solar wind carries with it the sun's magnetic field. The solar wind doesn't travel at a constant speed. Its speed varies depending on where it originates from on the sun. Some regions of the sun emit high-speed solar wind, while others emit slower wind. As the solar wind travels through space, it encounters the interstellar medium. The interstellar medium is the space between stars. It's not empty, but filled with gas, dust, and cosmic rays. The solar wind pushes against the interstellar medium, creating pressure. This pressure inflates the heliosphere, giving it its characteristic bubble shape. Think of it like inflating a balloon. The air you blow into the balloon represents the solar wind, and the balloon itself represents the heliosphere. The heliosphere is not perfectly spherical. It has a more elongated shape, like a comet with a tail. This tail is formed because the sun is moving through space. As it moves, the heliosphere trails behind it. The heliosphere is not uniform. It is a vast bubble-like region of space dominated by the solar wind, a stream of charged particles released from the upper atmosphere of the sun. It has distinct regions, each with its own characteristics. These regions are shaped by the interactions between the solar wind and the interstellar medium. These regions are defined by the behavior of the solar wind, which changes as it travels further from the sun. The first region is called the termination shock. This is where the solar wind, traveling at supersonic speeds, suddenly slows down. At the termination shock, the solar wind abruptly slows down. This deceleration occurs because the solar wind encounters the pressure of the interstellar medium. This happens because the solar wind encounters the pressure of the interstellar medium, which acts like a barrier. Imagine a river flowing into a lake. The point where the fast-moving river water meets the still lake water would be like the termination shock. The point where the fast-moving river water meets the still lake water would be like the termination shock. The river slows down as it merges with the lake, just as the solar wind slows down at the termination shock. Beyond the termination shock lies the Helios sheath. This is a turbulent region where the solar wind is no longer supersonic. The Helios sheath is a turbulent region. Here, the solar wind is compressed and heated as it interacts with the interstellar medium. Here, the solar wind is compressed and heated as it interacts with the interstellar medium. This interaction creates a chaotic environment, much like whitewater rapids in a river. It's a bit like the whitewater rapids that form when a river flows over rocks. The water becomes turbulent and energetic, similar to the solar wind in the Helios sheath. Finally, we reach the heliopause. This is the boundary between the heliosphere and interstellar space. This is the boundary between the heliosphere and interstellar space. It marks the edge of the sun's influence. It marks the edge of the sun's influence. At the heliopause, the pressure of the solar wind and the interstellar medium are balanced. At the heliopause, the pressure of the solar wind and the interstellar medium are balanced. This delicate balance creates a boundary that defines the outer limits of our solar system's influence. Section 5. The heliosphere's shield. The heliosphere plays a crucial role in protecting our solar system from harmful radiation. It acts as a vast bubble created by the solar wind that extends far beyond the orbit of Pluto. One type of radiation it protects us from is galactic cosmic rays. These rays are high-energy particles that travel through space at nearly the speed of light. Cosmic rays are high-energy particles that originate from outside our solar system. They come from supernovae and other energetic events in the galaxy. These cosmic rays can be dangerous to life. When they interact with living cells, they can cause significant damage. They can damage DNA and increase the risk of cancer. Prolonged exposure to cosmic rays can lead to serious health issues. Thankfully, the heliosphere acts as a shield, deflecting most cosmic rays away from our solar system. This deflection is crucial for maintaining the safety of life on Earth. The heliosphere's magnetic field also helps to protect us. It creates a barrier that prevents many of these harmful particles from reaching the inner solar system. The Sun's magnetic field, carried by the solar wind, forms a protective bubble around our solar system. This bubble is constantly being replenished by the solar wind. This magnetic bubble helps to deflect charged particles from the interstellar medium. Without it, these particles would pose a significant threat to life on Earth. Without the heliosphere, Earth would be bombarded by harmful radiation from space. This constant bombardment would make our planet a much more hostile place. This radiation could strip away our atmosphere and make life on Earth impossible. The atmosphere is essential for maintaining the conditions necessary for life. The heliosphere is essential for life as we know it. It acts as a guardian, ensuring that our planet remains a safe haven in the vastness of space. Section 6. Voyaging Beyond the Boundary. In 1977, NASA launched two spacecraft, Voyager 1 and Voyager 2. These spacecraft were on a mission to explore the outer planets of our solar system. But their journey didn't end there. After completing their planetary flybys, the Voyager spacecraft continued their journey outward. In 2012, Voyager 1 made history by becoming the first human-made object to cross the heliopause and enter interstellar space. Voyager 2 followed suit in 2018. These spacecraft provided us with the first direct measurements of the interstellar medium. Their data have revolutionized our understanding of the heliosphere and the space beyond. The Voyager spacecraft are still traveling through interstellar space, sending back valuable data about this unexplored region. They are our distant emissaries, carrying messages from humanity to the stars. Section 7. Unveiling the Secrets of the Heliosphere. The heliosphere is a complex and dynamic structure, a vast bubble-like region of space dominated by the solar wind, a stream of charged particles released from the upper atmosphere of the Sun. Scientists are still working to understand all of its secrets. This enigmatic region is crucial for protecting our solar system from cosmic radiation and interstellar particles. They use a variety of tools to study the heliosphere. These tools range from sophisticated telescopes to advanced computer simulations, each providing unique insights. These tools include space-based telescopes, ground-based observatories, and computer models. Each of these instruments plays a vital role in piecing together the puzzle of the heliosphere. One of the key questions scientists are trying to answer is how the heliosphere interacts with the interstellar medium. This boundary region is where the solar wind meets the winds from other stars. This interaction is constantly changing, influenced by various factors that make it a dynamic and ever-evolving frontier. It is influenced by factors such as the solar cycle, which affects the intensity and speed of the solar wind, and the movement of the Sun through the galaxy. As the Sun travels, it encounters different regions of interstellar space, each with its own characteristics. Scientists are also interested in learning more about the shape and structure of the heliosphere. Recent studies suggest it may not be a perfect sphere, but rather an elongated bubble. The heliosphere is not static. It is a dynamic entity, constantly being influenced by the solar wind and external forces. It is constantly being shaped and reshaped by the solar wind and the interstellar medium. This ongoing interaction creates a complex and ever-changing environment. Understanding the heliosphere is important because it can help us to learn more about the formation and evolution of other planetary systems. By studying its properties, we can gain insights into the processes that shape other star systems. By studying our own heliosphere, we can gain insights into the conditions that might exist around other stars. This knowledge is crucial for understanding the broader universe and our place within it. Section 8. The dynamic interaction. The heliosphere is not a static bubble, it is constantly interacting with the interstellar medium. This interaction is a dynamic process. The solar wind pushes outward against the interstellar medium. The interstellar medium in turn pushes back against the heliosphere. This push and pull create a constantly changing boundary between the two. The heliosphere's shape and size can fluctuate. These fluctuations are influenced by several factors. One factor is the solar cycle. The solar cycle is an approximately 11-year cycle of solar activity. During periods of high solar activity, the sun emits more solar wind. This increased solar wind pressure causes the heliosphere to expand. Conversely, during periods of low solar activity, the heliosphere contracts. Another factor that influences the heliosphere is the sun's movement through the galaxy. Section 9. A cosmic perspective. The heliosphere is a reminder of the sun's powerful influence. It extends billions of kilometers into space, creating a protective bubble around our solar system. But the heliosphere is also a reminder of our cosmic insignificance. As vast as the heliosphere is, it is but a tiny speck in the Milky Way galaxy. And the Milky Way is just one of billions of galaxies in the observable universe. The Voyager spacecraft, having crossed the heliopause, have given us a glimpse of the vastness of interstellar space. But even their epic journey is just a tiny step in the grand scheme of things. The universe is full of mysteries waiting to be explored. The study of the heliosphere and interstellar space is just the beginning of our exploration of the cosmos.